Hello and welcome to this video lesson. In this video lesson, we will be looking at the cosine law. To derive the cosine law, we're going to break down this triangle, which is triangle ABC, into two individual triangles by drawing 90-degree line which connects to the base over here. And we're going to label, we know that this whole length is a, so we can label this part as x and this as a minus x, this part over here. And by doing that, we have made two triangles, one right triangle here and one right triangle right here. Now for triangle ACD, we can use the Pythagorean theory to say x squared plus h squared is equal to b squared. And for triangle ABD, we can use the same logic and say that a minus x squared plus h squared is equal to c squared. And we can, for both of these, we can rearrange for h squared. For this one, we will get h squared is equal to b squared minus x squared. And for this one, we get h squared is equal to c squared minus a minus x squared. Once we've done this, we know that h squared is equal to this and h squared is equal to this, so we can substitute this equation into this equation. And by doing that, we get b squared minus x squared is equal to c squared minus a minus x all squared. Well, now we can expand the right-hand side, and we get c squared minus, and this breaks down to a squared minus 2ax plus x squared. And our next step, I'm just going to take out or distribute the negative. And now I'm going to move everything to the left-hand side except for the c squared. So I'm going to get b squared minus x squared plus a squared minus 2ax plus x squared is equal to c squared. And we can see that we got x squared and x squared here, which cancel out. And we're left with b squared plus a squared minus 2ax is equal to c squared. Now, this is interesting because this is saying that we can use b squared and a squared to find c squared. And we have a here, but we have x here, and we don't really want x, and instead we want to try to use an angle somewhere in our diagram and change this x to something that relates a lengths to a or b. So to do that, what we're going to do is we're going to use the cosine law, and I'm going to write this in green, and I'm going to use this angle c here. And we get cosine of c is equal to, we have a right angle triangle right here, so we can write adjacent here is x over the hypotenuse, and hypotenuse here is b. And if we rearrange for x, we get x is equal to b cos c. Now I'm going to substitute this into my x value here, because this x and this x are exactly the same thing. And by doing that, I will get b squared plus a squared minus 2a. Instead of the x, I'm replacing it with b cosine of c is equal to c squared. To write it in slightly better form, just rearranging things in terms of alphabetical order, we can write this c squared, which is kind of left-hand side what we're looking for, is equal to a squared plus b squared minus 2ab cosine of angle c. and this is our final equation. Just to make sure that everything is written properly, I'm going to write lowercase c because that just to distinguish it between the side length and the angle over here. So basically, based on this equation, we can see that c, so whenever we're trying to look for a length, that length squared is equal to the other two lengths squared added minus twice the length of a and b, which are the other two sides that we're not looking for, multiplied by cosine of the angle between a and b. And if we were to write these in other forms, I'm just going to write the other two forms. If I were to write a squared, then that would be b squared plus c squared minus 2bc cosine of angle between sides b and c, which is angle a. Or we can write this as b squared is equal to a squared plus c squared minus 2ac cosine of angle b. And these are all valid. And if you pay attention, actually, you will notice something. If we had an angle of 90 degrees, so if our triangle was just a right angle triangle, then cosine of 90 is actually 0. So this whole term cancels out, and we get a squared is equal to b squared plus c squared, which is pretty much the Pythagorean theorem. Note that the cosine rule can be used to find a missing side whenever you're given two other sides and an angle. And these two sides could be anywhere, and the angle could be pretty much anywhere. You can find the remaining side. And the cosine rule can also be used to find the angle given that all the other three sides are given. So if the three sides are given, you can find any of the angles within the triangle using the cosine rule. Okay, in this question we're asked to find the value of x, which is right here. And we can see that we have two triangles. We have this triangle, we have this triangle, we actually have three, and we have that one. So there's different methods of solving this, and this is actually not a 90-degree angle, even though it seems like it is. This diagram is just not to scale. And what we have to do is we got to figure out x. So one way to do it, and there's probably multiple ways of doing this, but we can treat this, we can look at this triangle, try to find this angle over here, and then use that angle to find this x value, because then we'll have this side, and the angle in between, and we can use that idea to find the x value. So let's try that. Let's find this angle first, and we don't really need to find the angle itself. We can just find the cosine of the angle and then plug it in, but we'll find the actual value just to show you that that's a possibility and how do we actually find it. So we're going to use, so I'm going to label this as theta, and I am going to say that 6 squared is equal to 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of angle theta. And what I've done here is this length and this is the length and this is my angle. So 6 squared cos theta, and in between, what goes in between is the 8 squared, the 5 squared, and minus 2 times the two lengths, and multiplied by the cosine of the angle in between them. So now we get, I'm just going to rearrange, and I get cosine of theta is equal to 8 squared plus 5 squared minus 6 squared divided by 2 times 8 times 5. Putting this in my calculator, I get a numerator value of 53, and I get a denominator value of 80. I can find angle theta. I'm actually going to keep this for now because this is really what I need. But to find theta, I just take the inverse value of the value that I got up there, and I get an angle of 48.5, and this is an approximated value rounded to 3 significant figures. Now I'm going to use the bigger triangle, which is this triangle here, and I'm going to use the same logic. Now I have x squared is equal to my side over here, which is 8 squared, my side over here, which is 7 squared, so 8 squared plus 7 squared minus 2 times 8 times 7, multiplied by the angle in between, which is cosine of theta. I'm going to expand the values. I got 64, I got 49. 2 times 8 times 7 should give me 112. And the cosine value of theta is calculated here as 53 over 8. Over 80, I apologize. And we can just plug that value in and we can do the calculation. And we get that x squared is equal to 38.8. And I can take the square root of that value, and x will equal to, or I'm going to approximate it as 6.23, and my unit is in meters. And I'm only taking the positive because length cannot be a negative value. And this kind of makes sense because if you look at the diagram, in this triangle we got the length of 6 here. This should be slightly bigger because this is only 2 meters here, so this shouldn't be much larger, but slightly bigger than 6, and it is. It's slightly bigger, gives us the value of 6.23.